Hey guys, welcome to Safi Mixed. In this video, I will talk about the construction in the uses of Cartesian coordinate system, both in 2-space and 3-space, but would like to begin from the definition of coordinate systems because we use different types of coordinate systems. A coordinate system assigns a pair of unique values of real numbers to each point in a plane, and similarly a coordinate system in 3-space, in 3 dimension, assign a triple of real numbers to each point in 3 spaces. When we say 2-space, that means we are dealing with a plane, and when we say 3 spaces, that means we are dealing with 3-dimensional spaces. So, in order to construct a Cartesian coordinate system, we draw a horizontal real line and locates the origin of the real lines. That is, we assign 0. Then to this side of the real line, we have positive values of the real numbers like 1, 2, 3, 4, and so on. And to the left of the real line, we have negative values -1, -2, -3, and -4, and so on. Then we take another real line perpendicular to this real line and draw it like this, in such a way that the 0 of this perpendicular or vertical line is exactly coinciding with the 0 of this horizontal line, and then the positive values of this real line are above in the upward direction. So this is 1, this is 2, this is 3, 4, 5, and so on, and the negative values of this real line lies below in the downward direction. This is -1, -2, -3, -4, and so on. These two perpendicular lines constitute what we call Cartesian coordinate system in a plane. This is, since these lines are perpendicular to each other, therefore this system is also called rectangular coordinate systems. We call it Cartesian or rectangular coordinate system. And now you see the Cartesian coordinate system in fact divide the whole plane into 4 different regions. This one region where this region which lies between the positive values of vertical and positive values of horizontal, this region which lies between the positive values of vertical and the negative values of horizontal, then this region lies between the negative values of horizontal and the negative values of vertical, and this one lies between the positive values of horizontal and the negative values of vertical. We in general we call the horizontal line, the horizontal real line, as x-axis. We call this x-axis, and the vertical line we call as y-axis. So we have 2 axes, horizontal axis and vertical axis. Then to the right of the zeros, at this point at which the 2 lines intersects, in fact corresponds to the 0 values of horizontal line, the 0 value of vertical line, and is termed as origin of the coordinates of the coordinate system. And the negative value side is usually represented with x prime axis, and similarly this one is written as y prime axis. So we have 2 axes, x, y, and then the negative values x prime and y prime. This region is called first quadrant. And this one is called second quadrant, this one is called third quadrant, and this one is called fourth quadrant. Now, if we take a point anywhere in this plane, let's say I consider this one point, And I want to assign values to this point. For that, I drop a perpendicular on x-axis first and let it meet with 1, though it is a bit to the right of the 1, but I call this 1. Let this is 1. Then the value along x-axis of this point, let me remove the, so that we are well clear, remove this and let me put the 1 over here, first one. Then let me call this point P. Then the value along x-axis I write as 1. And similarly, I drop a perpendicular on y-axis and let it meets with and 3. Then we write this as 3. So this pair of two numbers, 1 and 3, is unique for this point. No other points, no other point on this whole plane would have this pair of numbers. So this is unique. This is unique to this point. This pair of numbers is unique to this point. Because if I take another point, let's say at this position, if I drop perpendicular, it meets at 3 and y, but it meets at another point. Let's say this is 2.5. So this point Q, I call 2.5 and 3. So we say that the numbers, the pair of numbers for a point is unique. Or in other words, we say that there is a one-to-one correspondence between the value. There is a one-to-one correspondence between the points on the plane and the pair of numbers assigned to that point. Similarly, I can take a point at this position. Let's say if I drop a perpendicular, it meets at -3, and if I drop a perpendicular, it meets somewhere with 1.8. So this is a point, I call this R. R is a point with values -3 and 1.8. And these values, these numbers are called coordinate axes. This is called x coordinate and this is called y coordinate. The first number in every pair is called x coordinate and the second number is called y coordinate. Sometimes we use other names, like the values along x-axis are called abscissa. Abscissa correspond to x coordinate value. And then ordinate refers to the values along y coordinate. So we use different names. You can call abscissa, you can call ordinate, but in physics we generally call the value along x-axis, the value along y-axis. Similarly, x coordinate and y coordinate. We use words like that. Okay. Now, if we assign a third axis, if we attach a third axis to this plane, for example, an axis exactly perpendicular to the board, that's one axis. Then this three axes, the set of three axes then represent a three space. Then we have this axis extending to this direction, this axis extending to the backward. So this axis, the perpendicular to the plane in this one direction, it takes positive values, and in the backward direction it takes negative values. So this axis is generally called the z-axis. And on for graphical purposes, we represent the three space axes like this. We take usually we take x-axis in this direction, y-axis in this direction, and z-axis then in this direction. Then the point at which the three axes intersect or meet with each other, then this point is called origin. And the values of all the three axes at this point is 0. That is, origin, which is usually represented with O, has the numbers, the triple numbers with values with each with 0, 0, 0, 3 zeros. That means that the coordinate of x-axis is 0, y-axis is 0, and z-axis is 0. Now, there are two types of the coordinates in 3-dimensional. We call it right-handed and left-handed. It is right-handed if I curl the fingers of my right hand from x to y, and the thumb then represents the positive value of z-axis. This is then right-handed. And if I change this notation from X and this to Y, and curl the fingers of my left hand from X to Y, then the thumb points in the direction of positive Z axis, then this system is called left-handed. So we have left-handed coordinate system, we have right-handed Cartesian coordinate system. And whether left-handed or right-handed, we always assign triple of numbers, triple numbers to every point. That is, if we have a point somewhere at this position in the above the plane, somewhere at this position. So if I want to represent this point on the plane, I call this P. I will put three numbers. So that is not possible because so I just draw this point to be somewhere over here, and I write it P. And this P has some values. Let's say 2, 5, and 3, something like this. And then this first number corresponds to the value along x-axis. The second number corresponds to the value along y-axis. So let me be on right-handed coordinate system. Then this value corresponds to x-axis, this value corresponds to y-axis, and this number corresponds to z-axis. In fact, we have different planes in 3-space. When we say 3-space, means we are dealing with 3 dimension, and when we say 2-space, that means we are dealing with a plane in 2 dimension. In 3-space, we have different planes like XY plane. This is the plane between x and y axis. Then we have XZ plane. This is the plane between x and z axis. Then we have YZ plane. This is the plane between z and y axis. And similarly, there are planes with negative values of the 3 axes. Overall, the 3-space is divided into 8 different regions, and every region is called the region between x and y, the region between minus x and y, the region between x and z, the region between minus x and z, and so on. So we have there, and every single region is called an octane. And the octane between the three and obtained between the 3 positive values, that is in the region on which all the points has positive 3 real numbers, is called first octane. The rest 7 octanes have no special names, has no order names, but the first one with all the 3 real numbers being positive is called first octane. So this way we represent points in a plane by using 2-dimensional Cartesian coordinate systems, and in a space in 3 dimension we use 3 coordinates axes, 3 coordinate axes. And remember the pair of numbers in 2 and the triple of numbers in 3 space are unique for every point. No 2 points would have the same number of all the 2, in this case, numbers, and all the 3 in 3 space numbers. So every point has a distinct set of numbers, a pair or triple. At the end, thanks for watching.